Hello, my dear friends, welcome back. So, today we are going to start with a new chapter of class 12, chapter 9, Differential Equations. So, this comes in the last chapter of the calculus portion, that is actually after differentiation and continuity, application of derivatives, integration, application of integration, integrals, and after that, only this chapter comes differential equations. So, which also means that uh, for this chapter we will need a very clear concept of differentiation and integration, so at least the basics, so which I believe all of you are very well familiar with. Now let's get straight to the chapter here, differential equations. Now what is this chapter all about now? Differential equations, frankly speaking, it's not a very complicated chapter, at least as of class 12. So as the name suggests, this is an equation. Okay, this is an equation of differentials, and that's why of course it is called differential equations. So now see, as we know, we are all familiar with the term dy by dx, dx, where this dy by dx actually represents change in y with respect to x. So that clearly tells that y is a dependent variable here and x is the independent variable. Just like area, the relationship between area of a circle and radius of a circle. So radius is the independent variable and area is the dependent variable, because area of a circle depends on radius, isn't it? So according to the radius only, area of a circle changes. So that's why radius becomes the independent, area is the dependent variable. So something like that of a relation. Okay, so this concept also will be required. Okay, so here when we write dy by dx, it means y is the dependent variable, x is the independent, because y depends on x. In application of derivatives also this is done. Now before we really move into differential equations, let us first understand what is an equation. So as we all know what is an equation, so I'll just give you some examples because we are all very familiar with what are equations. So we have already come across linear equations in one variable, like 5x is equal to 20. So this was a linear equation in one variable. We have come across linear equations in two variables, like x plus y is equal to 4. So these were linear equations in two variables. Then get the feel, okay, here, because we are talking about equations. What equations? Differential equations. So I think by now you can somehow assume that we are going to be dealing with equations of differentials. Now what are differentials? I'll tell you for those who do not know. And we have also come across like quadratic equations, 2x plus y, x square plus 2x plus 3 equal to 0. Then in class 11, if you remember, we have come across trigonometric equations like cos of 2x is equal to 1 minus 2 sine square x, and inverse trigonometric equations, logarithmic equations. So we have come across, those were all equations as per the name, trigonometric equations where which consist of trigonometric functions. Now what will be now differential equations? But before that, again, what are differentials then? What are differentials? Differentials are nothing, as I mentioned here. We have come across dy by dx, d square y by dx square, d cube y by dx cube, first order, second order, third. Of course we have done up to second order only in class 12, but it can go on third order, fourth, nth order. These are all known as differentials. Okay, these are all known as differentials. So that means we can simply, in simple words, we can say that an equation in which differentials are involved is known as a differential equation. Okay, an equation in which differentials are involved is known as a differential equation. So like, just for example, this is a normal equation, this is a algebraic equation, this is or polynomial equation, this is like a trigonometric equation. So this will be just replaced, these variables will be replaced by differentials. So that means maybe we can have like dy by dx plus 2 equal to 0. So here what do we have? Instead of the variable, now variables will be just replaced by differentials of any variables or any functions, not functions, I mean of different differentials. So we can have one variable, it can have two variables. So sometimes even like dy by dx plus twice of d square y by dx square plus 3 equal to 0. So here what happens, we can see that there are differentials involved. Instead of the variables, there are differentials involved. So that's why an equation in which differentials are involved are known as differential equations. So if you can just get that feel that we are not going to be doing something very different. We're just going to be dealing with equations, but instead of like trigonometric equations where trigonometric functions are involved, here we will be dealing with equations where differentials are involved. Just that now functions will change. That's all. Differentials will come and take their place. Okay, I hope you've got a slight feel on that. All right. So mathematically, what is a differential equation? It is an equation containing an independent variable, a dependent variable, and the derivatives of the dependent variable is called a differential equation. For example, like this: d square y by dx square minus 2 dy by dx plus 3y equal to sine x. So if you look at this, what is the dependent variable? As I said, y depends on x, y depends on x, so y is the dependent variable. X, because y depends on x, so x is the independent variable. And do we have the derivative of the dependent variable, dy by dx, dy by dx? Of course. So this is a differential equation. What about this? This is also a differential equation where differentials are involved. Not that all the terms are differentials. Are differentials involved? Yes, that's it. What happens with the rest of the terms? That's really not our concern. Differentials are involved, no? Yes. So it becomes a differential equation. Alright. But whereas this, here we do not have any differentials, isn't it? So this is not a differential equation. This is simply polynomial equations. Getting that feel, no? Right. Here no differential dy by dx or dx by dy or dy by dz. Nothing is there. Simple variables. So this is not a differential equation, this is a polynomial equation. Whereas here differentials are involved, so these are differential equations. Okay, all right. Now what will happen is, in this chapter we will be having 6 subtopics. One is the order and degree of a differential equation. Second is the general solution and particular solution. Third will be formation of differential equations. And then after that we will be learning how to solve differential equations, how to find solution of differential equations, under which we will be having by variables separable, by homogeneous differential equations, and linear differential equations. So one by one we will be learning all of this stuff. Okay, now let's learn this topic, that is the first topic, that is order and degree. So I want you to stay with me here till the end of the video, so that we can just clearly just clean up this order and degree. Okay, you might get a 1 mark question, multiple choice questions and all from this topic. Okay, order and degree of a differential equation. Now before we go for order and degree of a differential equation, let me tell you once again, let me try to simplify differential equations once again, not one again. Differential equations. So definitions and all mentioned, but simple definitions which we try to make you understand. So for example, we can also say that what is a differential equation? It's like a polynomial, polynomial in derivative. What did I say? Equations which have differentials. So in other words, but there are some conditions. Okay, there are some conditions, and those conditions of course will be learning in detail again. So before that, let's just quickly learn more about what is a differential equation, because when we talk of order, it's not going to be difficult for you, but when we talk of degree, that's where we will really have to know some basic stuff. So before we really go to that, let's build up more on this differential equations so that our degree, the concept will be clear. So in other words, we can also say that a polynomial in derivative can also be called as a differential equation, something like that. But before that, again, what is a polynomial? If you remember, like, how can I say, like, what is a polynomial? Maybe a simplified way, like, okay, it is an expression. We have already done this in our lower classes. Now it is an expression which consisting of variables, right, and coefficients, and involves, like, for example, like only like addition, subtraction, I'm writing in short only, okay, multiplication, and non-negative integral. Integral means integers, non-negative integral exponents, or in other words, only positive powers of the variables. So this was a polynomial, isn't it? It is an expression which consists of only addition, multiplication, and division. Multiplication and subtraction, no division here. No division, careful. So it's only addition, subtraction, multiplication, and the powers should be, whatever be the powers, it should be only positives or non-negative integers. So positive natural numbers, something like that, including, of course, 0 is also possible, constant polynomial. So examples like 2y minus 4z, this is a polynomial. If you write equal to 0, then of course it becomes an equation, right? When we equate a certain polynomial to a certain value, then it becomes an equation when the two sides are equal. So like this is a polynomial, isn't it? Or we can have some more polynomials, like we have done so many polynomials, like 2x plus 3y, this is also a polynomial. 2xy plus 3z, this is also a polynomial. So I think polynomial is clear, like, but before that, like, what about 2y power minus 1 minus 4z? Is this a polynomial? This is not a polynomial, because as I said, we should be concerning, it should involve only positive exponents, only positive powers. So this is having a negative power, so definitely this is not a polynomial. Okay, try to get to the point here, understand. Or what about 3 root over of x plus 4y? So maybe we can think, okay, I can write this as 3x power 1 by 2 4y. So it's positive, of course it's positive, but again, if you remember, non-negative integral exponents, integers only. So 1 by 2 is not an integer, so it should not involve fractions also. Exponents only, non-negative integers only. So even this is also not a polynomial. 3x plus 4y by x. So you can see no division involved with the variables and with the variables and all, because x, if you write it, then you will have to write it as 4y x power minus 1. So this is also not a polynomial, right? So you're getting the feel of a polynomial. So what will happen is, what is a differential equation in a more simple way? Something like a polynomial which involves derivatives. So what if I just replace the variables by differentials to, like, dx by dy plus 3y? No problem, because see, differentials, instead of this I just replaced it with differentials. Or maybe even here also I can write dy by dx also, no problem, because differentials are involved. Or like 2 d square x by dy square plus 3 dx by dy equal to 0. So what happens here is, like, see, the variables are replaced by differentials. So it's like polynomials in derivatives or in differentials. So when I say polynomials, that means these differentials should have only when you talk of, this is order only, so when we talk of powers or exponents, it should be only positive or non-negative exponents, right? It should not be involving different division, like for example 2 dy by dx plus 1 by dy by dx. Now this is not allowed, because you see 1 by dy by dx, so maybe some of the equations can be transformed, but as of now this is not allowed. So maybe we'll have to take the LCM, and maybe we can try if we can convert it in the polynomial form, and then we end up with positive integers, no problem, fine. Okay, so these are polynomials in differentials. I hope you're clear with that now. So these are simply equations only. Now polynomials, equations. All right, clear? Now when we talk of this, the first topic, that is order, it's very simple. The order of the highest order derivative, or the power of the highest order derivative occurring in a differential equation is called the order of a differential equation. Can you get the point here? The order of the highest order, the order of the highest order derivative occurring in a differential equation of the highest order, very important here, of the highest order derivative. So like examples, like see, d square y by dx square plus 3 dy by dx whole cube plus 2 equal to 0. 2, let's say y. So is this a differential equation? Of course it involves differentials, and about the other variables, as I said, we are not concerned because it involves polynomials in differentials. Okay, polynomials in differentials, get that point? It will be more clearly defined when we come back to here again. So this is a differential. Now what is the highest order here? What is the highest order derivative here? The highest order derivative is d square y by dx square, isn't it? dy by dx, it's first order derivative. That means you do differentiation once. d square y by dx square is second order derivative. That means you have applied differentiation 2 times. d cube y by dx cube is, it means you have applied differentiation 3 times. That is called the order of derivative, isn't it? And what do you mean by order of differential equation? It is the order of the highest order derivative. So what is the highest order derivative here? What is the highest order derivative here? The highest order derivative is this one. And what is the degree or order of this highest order derivative? 1. So what is the order here? Order will be 1. All right, that means the order, highest order derivative. Sorry, highest 2. What man? I'm talking about degree now. Highest order derivative here is 2. So I hope you understand the highest order derivative. Like for example, again, d square y by dx square whole cube, like plus y into dy by dx power 4 plus y square equal to 0. So what will be the order here? Order of this differential equation. Order means we will now simply look what is the highest order derivative. So this is differentiated only once. This is differentiated twice, d square y. So order, we are not looking into the exponents, powers. Okay, order means highest order derivative. So maximum, how many times has it been differentiated? 2 times. So order is 2. That is what we are talking. How many times has the differentiation been applied? That is called order. Getting the point? No, in a given differential equation, what is the maximum times the differentiation has been applied? Okay, that is called order of a differential equation. Okay, so with more examples we will be definitely solving more. I hope it's clear. Even like for example, like dy by dx whole square plus 5y equal to sin x. So here also you see dy by dx differentiation applied only once, isn't it? Maximum times is only 1, so order is of course only 1. This is exponent order, not degree. How many, what is the maximum time differentiation has been applied? Yeah, something like that. Okay, clear? All right. Now this is slightly complicated, but yes, I'll try to make it very simple for you. That is, what do we mean by a degree of a differential equation? The degree of a differential equation, if defined, is the power of the highest order power of the highest order derivative, power of the highest. So your first job is to find the order and then its power occurring in a differential equation after it is made free from radicals and fractions. You remember polynomials I was talking about? No, that's why I cleared that topic first, right? There, after that only we can comment on the degree. So it doesn't mean that every differential equation's degree can be defined. No, there are differential equations whose degree cannot be defined. Order will be defined, degree will not be defined. Okay, so now when we look here, the same example, d square y by dx square plus 3 dy by dx whole cube plus 2y equal to 0. Order, your first job is to find the order. Order is 2, this one. And what is the power of this second order derivative? Power to only 1. So degree will be 1. What about the second one? D square y by dx square whole cube plus y dy upon dx whole power 4 plus y square equal to 0. What is the order here? Highest maximum number of times the differentiation has been applied, 2 times. So now that means I am not interested in this part at all. Order choose ho gaya bas. Now degree means exponent, so this second order derivative has a degree 3. Samjha? Okay, but now the question is if defined. That means if it is not a polynomial in a derivative in differentials, then it is not defined. Meaning, look at this carefully. Dy by dx plus sine of dy by dx is equal to 0. What will be the order here? Of course, order will be 1. What will be the degree? Degree will not be defined. Now how? I see differentials. But what did I say here? It should be polynomials in differentials. Now in polynomials, if you remember, what were the operations that we could apply? In polynomials, the operations that we could apply, if you remember, was addition, subtraction, multiplication, and the power should be non-negative integers. But what do we have here? So like it's something like this. If we assume this to be a variable, the differential. So in the differential, no other functions in the differentials. What is a see, this is in the differentials, no other functions should be applied except plus, minus, multiply, power. What do I see here? On the differential, trigonometric function is applied. So this is not allowed. Remember, no? Polynomial in derivatives. Polynomial in derivatives. It is an expression consisting of this. Okay, now I'm going to confuse you more now. So before we really go for degree, we should see to it that we write the equation as a polynomial of derivatives. Polynomial of derivatives, as I said, no negative or fractional powers are allowed. Powers of the derivatives should be natural numbers or non-negative integers. This is more precise. Okay, right? Now coming back to that degree part again. What did I say? I said, so you are really confusing us a lot. No, see, dy by dx. Let's talk of degree only, okay? Sine dy by dx equal to 0. This is not a differential equation because, as I said, We have differentials, yes. So sir, this is also differential, yes, but what are you forgetting? If you are clear with this idea now, you will be able to, many students, they will make mistakes in degree only. Order though very simple now, degree only many students will make mistakes, because these 3 points have to be kept in mind, and especially these polynomials. What did I say? Polynomials only on the differentials, that is dy by dx, d square y, whatever be that, only 4 operations, I mean basically 3 operations are allowed: plus, minus, multiplication, and its power should be positive. But I did not say here that you can apply trigonometric functions on the differentials. I did not say you can apply exponential functions on the differentials. I did not say you can apply logarithmic functions on the differentials. I did not say you can apply inverse trigonometric functions on the differentials. So if you find this on the differentials, it is not defined. Like dy by dx plus e power dy by dx equal to 4. This is also not defined. Order is there, 1. Order means dy by dx. But degree, no, because it is not defined. Because it is not a polynomial of derivatives. Clear, no? But now, let me make it more interesting for you. What about this? Is this, okay, order 1. Degree, immediately, whoever is watching this, immediately I want you to answer me here. Immediately put it on the comment section below and tell me immediately. Don't, let's be honest with each other. Immediately I'll tell you the answer. But you, if you're watching this, please go to the comment section, tell me what will be the degree of this equation. Not defined or 1, because order is 1, so its power is 1. So is it going to be not defined or 1? Immediately, it doesn't matter even if you're wrong. The answer will be, it is 1. Then you will be surprised, array, what is happening here? Why is it not defined? Array, look at this carefully. What is the difference with this two? Dy by dx, sine dy by dx, sine x. I said no other function except addition, subtraction, multiplication is allowed on the differentials. I did not say on the variables. No. So here there is no differential. Trigonometric function is applied on x only. So we are concerned with the differentials only. We are not really concerned with what happens with the other variables. Choro na, goli maro. So no problem at all here. Even dy by dx plus e power y equal to sine x, and no problem. Here also dy by or d square y by dx square. So order 2. Degree also existing. Degree is power 1. Okay. Because here is exponential function applied on the differential? No, variable only. Here also a sine trigonometric function, is it applied on the differential? No, it's applied on the variable only. So this is defined. So degree will be there, 1. Are you clear? Are you clear with the concept? I hope so. Okay. All right. So I believe that I have been able to clarify your concept. Okay. Now let's quickly move on to the exercise. Let me just solve the exercise also. A small exercise. Exercise 9.1. Question is, determine the order and degree. Again, you will see in the bracket they have written if defined of the differential equation. Chalo, quickly. Number 1, d power 4y by dx power 4 plus sine of y. Triple dash means triple or yeah. So triple dash means d cube y. Okay, let me just write d power 4y sine d cube y by dx cube is equal to 0. So what is the order? Order means, we don't think, order means maximum how many times is differentiation being applied? 4 times, na? D power 4. But degree, degree. You see, sine trigonometric function is applied on this time on a differential equation. Yes, exactly. So it is not going to be defined. So since it is a differential equation, but for degree it is not defined. Since the differential equation, you can write this carefully, okay? So that from the next questions, if we come across this, I will just dictate this, you can just write it down, okay, so that we can save some time. So since the differential equation is not a polynomial, equation in dy by dx, therefore dy by dx means representation on a d can be dq for differentials na. Therefore its degree is not defined. Clear na? I hope things are getting better now. Number 2, where is 2? Y dash plus 5y equal to 0. Y dash means dy by dx plus 5y equal to 0. So what will be the order here? And degree? Order, highest order, only 1 times. Degree, power 1, no problem. Number 3. ds by dt power 4 plus 3s d square s by dt square equal to 0. So what will be the order and degree if defined? Order, highest maximum times differentiation is applied, d square s, here ds only, so 2 times, so order is 2. Degree, so this is not our concern now, because order, after order only the power exponent of the order will be the degree, so power 1 bus degree 1, okay. So order will define the degree for us. Number 4, d square y by dx square whole square plus cos of dy by dx is equal to 0. So you know the answer. What will be the order here? Order of course is 2. Degree, what will be the degree here? Degree will be not defined, okay, but please write down like this one, okay. Since the given differential equation is not a polynomial equation in dy by dx, therefore its degree is not defined. Here, just to save some time, I'm just writing not defined, okay, but every time please write this if it comes for you to write. If it's a multiple choice question, no problem. Now, because on the differential you can see that trigonometric function is applied, but only addition, subtraction, multiplication is allowed. No other functions is allowed on the differentials. On variables allowed. 5. That was 4, right? 5. d square y by dx square is equal to cos 3x plus sin 3x. No problem here, I believe. What will be the order? Highest order derivative 2. Degree 1, because its power is 1. Right, because cos here is not, I mean it's not defined, I mean it's not expressed in differentials, no, dy by dx, no, it's expressed in a variable only. So as I say, that's okay, no problem. It should just not be applied on differentials. Bas. Number 6, y triple dash square plus y double dash cube plus y dash 4 plus y 5 equal to 0. If you want to write order, highest times differentiation has been applied, here once, here 2 times, here 3 times, so order is 3. Degree, so since order is this is not our concern. Degree, power of the highest order. Getting it now? Y triple dash 2y double dash y single dash. I think you can just easily guess. D cube y by dx cube plus twice of d square y by dx square plus dy by dx equal to 0. So what is the order here? Order maximum times differentiation applied 3 degree 1. Hmm, 8 y dash plus y equal to e power x, that is dy by dx plus y equal to e power x. So order 1 times degree, no problem, degree 1 only, because exponential function is not applied on a differential, na? It's applied on a variable. As I said, variable apply kitna, no problem. Y double dash plus y dash whole square plus 2y equal to 0. So double dash means second order derivative. So what will be the order here? Highest order 2 times, no? Degree. So once we know that this is the order, degree will not come from here, no? Will come from here only. So it's power 1. I'm just writing directly, okay? Power 1. Clear? Okay, so lack of space, so I'll just go to number 10 here. Here, it's okay, number 10. Will that be fine, I guess? No problem, no? I'll do number 10 here, okay? So 10, 10, 10, 10, 10, 10, last one, that is y double dash plus 2y dash plus sine y equal to 0. So that is d square y by dx square plus 2 dy by dx plus sine y equal to 0. So order, how many times differentiation has been applied? Maximum 2 times, no problem. Degree also, any problem? Any other function applied on a differential? I don't see here, here also I don't see, because sine is applied on y only. So degree will be power of the highest order derivative only, so degree is going to be 1. So I am sure now, by now you are very clear with this. Okay, so if you really like this video, please do let me know in the comment section below, so that I can also get better and better and better for you. Alright, please do not forget to like the video, subscribe and share. Alright, so I hope this will be easy for you. Okay, so study well, do well. I'll see you in the next video with the next topic. That is, what was our next topic? Rewinding back, our next topic will be general solutions and particular solutions. Okay, so I'll see you there very soon. Study well. Bye bye.